Beneath the vast, dark cloak of space, an extraordinary cosmic event unfolds that is rewriting everything we thought we knew about our universe. Right now, 3I/Atlas is doing something so unexpected, so baffling, that scientists are scratching their heads in shock. You might feel a shiver down your spine as the data floods in. Unpredictable, mesmerizing, and maybe even a little terrifying. This isn't just another space anomaly. It's a glimpse into the unknown, pushing the limits of our understanding and forcing us to reconsider what's possible out there. Stick around, because what's happening with 3I/Atlas could change everything we think we know about the cosmos, and you won't want to miss it. The birth of 3I/Atlas, a new cosmic phenomenon. Detection of 3I/Atlas has sent ripples through the astrophysics community because it defies conventional expectations about what comets, or even interstellar objects, can do once they enter our solar system. Unlike typical comets or asteroids, this object exhibits an unconventional trajectory that hints at a more complex origin. Instead of following the predictable elliptical orbit driven solely by the sun's gravity, 3I/Atlas seems to be behaving as if influenced by an unseen force or perhaps even harboring internal mechanisms that we haven't encountered before. It's almost as if we are witnessing a cosmic anomaly that challenges the very foundations of our understanding about small bodies drifting through space. What truly stuns scientists, though, is how swiftly it appears to be changing direction and brightness, suggesting a volatile composition or an active process occurring on or within the object. Normally, comets develop a glowing coma and tail when approaching the sun because ice vaporizes. But 3I/Atlas exhibits a peculiar flickering pattern and unpredictable shifts in brightness that cannot be explained by simple sublimation. This points toward either an entirely new kind of material, possibly complex organic compounds or even some form of artificial surface, or some exotic interaction with the solar wind that we haven't theorized yet. Imagine, amid the vast solitude of space, an object responding to forces in ways that challenge our physics textbooks. The birth of this cosmic entity isn't about its formation millions of years ago, but rather how we first uncovered it. Its discovery was prompted by a sudden spike in brightness captured by automated sky surveys, catching astronomers off guard because it appeared in an unlikely part of the sky and moved at an unusual angle. As follow-up observations intensified, they revealed a shape and movement combining traits of both cometary and asteroid-like bodies, but with unprecedented quirks. The fact that 3I/Atlas is possibly not native to our solar system has deep implications. If these behaviors are indicative of some artificial structure or technology, however speculative, it could mean we're witnessing a form of interstellar visitation unlike anything imagined before. Every observational update leaves us with more questions than answers. It's as if the universe has secretly been hiding phenomena that challenge every rule in the cosmic playbook, and 3I/Atlas is now our front-row ticket to that unknown. As detectors continue to monitor its acceleration, composition, and possibly even its internal structure, scientists realize they are just beginning to grasp a glimpse of a new facet of interstellar material or technology. We stand on the cusp of an exciting revelation, feeling a mixture of awe and cautious curiosity, knowing that what we observe today might rewrite our understanding of the universe's true diversity. Unraveling the mysteries of 3I/Atlas's composition. The realization that 3I/Atlas defies conventional asteroid classifications has sent ripples through the scientific community. This object exhibits an intriguing hybrid nature, part asteroid, part comet, challenging long-held assumptions about what makes up these celestial wanderers. Spectroscopic analyses reveal a surface composition rich in complex organic molecules, silicates, and a surprising abundance of volatile ices, suggesting a layered interior that preserves primordial material from the early solar system. The spectral signatures differ remarkably from typical main-belt asteroids, hinting at an origin more akin to icy cometary bodies or even a transitional object formed in the distant Kuiper belt before being nudged inward. As researchers dissect the data gathered from advanced telescopes and space-based observatories, a pattern emerges. 3I/Atlas's surface shows signs of recent activity, including episodic outgassing and dust ejection, despite its classification as an asteroid. This hints at a composition capable of sublimating ice, releasing gases when heated during its close approaches to the sun, detecting organic compounds, such as polycyclic aromatic hydrocarbons, coupled with silicate minerals suggests a complex interplay of material that can unlock clues about the early solar system's building blocks. Laboratory simulations of spectral data tie these observations to objects akin to dormant comet nuclei, but with surface features that resemble some asteroids in dynamically and physically subtle ways. Further probing with radar and infrared observations points to a layered internal structure that is inconsistent with typical monolithic rocks or icy comets alone. Instead, 3I/Atlas might harbor a porous, conglomerate interior, a chaotic mix of ice, dust, and organic-rich material. Such complexity indicates that it could be a fragment of a larger parent body that once orbitally migrated inward, disrupted by planetary encounters or thermal stresses, exposing its heterogeneous interior. From a compositional standpoint, this diversity creates a tantalizing puzzle. The object might be a fossil record of planetary formation, preserving untouched materials from the early solar nebula, but rearranged in a way that confounds neat classifications. Understanding what 3I/Atlas is truly made of involves peeling back the layers of observational data that often conflict or overlap. Its unusual composition directly informs models of planetary accretion and migration, making it a prime candidate for future sample return missions designed to extract pristine material from its surface. The excitement isn't just in identifying its makeup, but in recognizing how such a body blurs the line between the asteroid belt and the distant icy reservoirs. It might be a missing link, giving insight into how early planetesimals evolved, persisted, or disintegrated over billions of years. The ongoing analysis promises to reshape not just our understanding of 3I/Atlas, but the very narrative of solar system formation itself. Unexpected trajectory and velocity challenges. The trajectory of 3I/Atlas has taken a sudden and bewildering turn that has left astronomers scratching their heads. Instead of following a predictable path dictated by the sun's gravitational pull and known perturbations, the comet-like object is veering off in a direction that defies existing models. It's as if some unseen force is tugging at it, or perhaps a series of gravitational anomalies are subtly tossing it around like a cosmic marionette. Witnesses monitoring its position through telescopes have reported a sharp acceleration, its velocity skyrocketing unexpectedly, making it a moving target far faster than anticipated. This isn't just a slight deviation. It's a roar of motion pushing against the established understanding of how such objects should behave when hurtling through a gravitational field in interstellar space. In particular, the challenges to calculating its velocity stem from the rapid shifts in its speed as it approaches what scientists believe might be a densely populated region or a nearby celestial body. Regular orbital calculations assume negligible influence from unknown variables, but 3I/Atlas appears to be breaking all these rules. Its apparent acceleration could suggest the presence of an unaccounted-for mass, possibly a massive asteroid fragment, a dark matter filament, or even an uncharted planet, exerting gravitational influence. The sudden change in trajectory feels almost alive, as if the object is reacting dynamically to forces we haven't fully mapped or understood yet. This heightens the mystery, igniting questions about the fundamental laws governing motion for interstellar objects pinballing through our solar system. What makes this even more unsettling for scientists is the unpredictability of how velocity shifts manifest in real time. Precise tracking involves painstaking calculations based on prior positions, but these shifts warp those assumptions entirely. When the object's velocity spikes unexpectedly, it can cross prediction models in mere hours. The core challenge lies in recalculating the forces at play, often requiring advanced simulations and the incorporation of variables not included in previous models. There's an ominous tension in the air. Each new observation feels like witnessing a piece of our understanding unravel, as if the universe is teasing us with its hidden complexities. This isn't just a puzzle. It's a wake-up call that cosmic dynamics still hold many secrets. The uncertainty surrounding the forces acting on 3I/Atlas has led to intense debate and speculation, especially because current physics cannot fully account for such dramatic velocity changes without invoking new or exotic phenomena. Some propose that small gravity assists from unseen objects are causing these surges, while others entertain ideas of unknown interstellar medium interactions or even alien influence, though these are more fringe theories. What remains clear is that the comet's unexpected trajectory and velocity challenge our ability to predict its future path with confidence. As it speeds through the cosmos, each passing moment might reveal more mysteries or rewrite the rules of celestial mechanics, both thrilling and terrifying in their implications. Unprecedented activity and anomalous behavior. Scientists are watching in disbelief as 3I/Atlas exhibits patterns that defy any known celestial behavior. For decades, the comet-like object was categorized as a typical interstellar traveler passing through our solar system, but recent observations have turned this assumption on its head. Instead of the anticipated slow, predictable trajectory, 3I/Atlas is behaving as if it's alive with inexplicable bursts of activity. Small but frequent outbursts flood the telescopic images, casting dazzling irregular glows across the dark night sky. The activity is not only unusual but appears to be intensifying, with each observation revealing new, unexpected phenomena. What's truly astonishing is the anomalous behavior that defies gravitational models and cometary physics. Instead of a steady, predictable orbit, 3I/Atlas veers erratically, with sudden shifts in velocity and unpredictable tumbling movements. Its brightness fluctuates dramatically over mere hours, as if some internal mechanism is causing intense, short-lived emissions of energy and particles. These sudden bursts sometimes dwarf the intensity of typical solar system comets, almost resembling a star suddenly flickering in violent, irregular patterns. Yet here it is, drifting through the void, unanchored to any celestial body that could explain such behavior. The activity doesn't stop at flickering light. High-resolution spectroscopy shows strange chemical signatures that don't correspond to anything in known comets or asteroids. Instead of a shell of icy volatiles sublimating smoothly as it approaches the Sun, 3I/Atlas releases massive jets of unusual particles, including isotopes that are rarely seen or understood. The irregularity of these emissions suggests some kind of internal process, perhaps even unknown chemical or physical mechanisms, that are actively reshaping how we interpret interstellar objects. In some instances, the object appears to shed fragments or debris, further complicating its anomaly-laden profile. This level of unpredictable activity prompts a wave of speculation among astronomers. Normally, celestial bodies follow the predictable rules of physics, gravity, thermodynamics, chemical reactions, yet 3I/Atlas seems to be rewriting those rules in real time. Its behavior has parallels with phenomena observed in active asteroids or main-belt comets, but nothing matches this intensity or erraticism outside of theories involving artificial origin or unknown natural processes. Scientists are caught between awe and trepidation, sensing that what they're witnessing could reshape fundamental understanding of interstellar objects and the limits of physics itself. For now, every new observation feels like peering into an unfathomable cosmic enigma, blurring the line between what's natural and what's potentially extraordinary. Implications for existing cosmic models. Scientists are currently reeling from the astonishing activities of 3I/Atlas, an interstellar object that has defied expectations in ways that could rewrite much of what we thought we knew about the cosmos. Its erratic trajectory and unexpected physical properties have already raised eyebrows, disturbed theories about the nature of small interstellar bodies, and challenging our assumptions about the composition and behavior of objects that drift through our solar system. What makes this object so unnerving isn't just its unusual speed or trajectory, but the possibility that it could be an artifact from an entirely different kind of astrophysical process, perhaps even evidence of alien technology. This unexpected behavior signals potential cracks in existing models of small body dynamics. Traditional understanding suggests that interstellar objects, having spent eons traveling through the cold void between stars, should resemble icy comets or rocky asteroids similar to those we've cataloged in our solar system. But 3I/Atlas is exhibiting surface features and activity patterns inconsistent with those expectations. It appears to be emitting unusual outbursts and showing signs of structural fragility. These phenomena suggest that our models about formation and aging of interstellar objects might be incomplete or outdated, especially when it comes to their physical integrity and the processes that activate surface vents or release material in transit. The implications stretch even deeper into the realm of cosmic evolution theories. Many models posit that objects like 3I/Atlas are simply cosmic leftovers, resilient remnants of planetary formation, drifting silently through space. But if this object behaves in ways that resemble artificially structured material or exhibits signs of an engineered surface coating or internal architecture, it throws a wrench into those assumptions. Could it be that some interstellar objects are not purely natural but have undergone unknown processes, perhaps even some degree of technological modification? If so, it demands a reassessment of how we interpret interstellar debris, and whether the census of natural objects might be missing clues to more exotic origins. Moreover, the findings force us to revisit the cosmic environment's energetic interactions. Existing models explain that small bodies pass through interstellar space relatively untouched for eons, but suddenly observing 3I/Atlas's behavior hints at ongoing processes that aren't accounted for. Possibly the influence of external factors like unusual radiation fluxes or magnetic fields that could alter an object's surface or internal composition. This throws open the door to new hypotheses that challenge the thermal and collisional evolution frameworks long considered to be universal. It's as if we are only just beginning to scratch the surface, peering into a universe that holds surprises far beyond our current understanding, blurring the line between natural phenomena and potentially engineered artifacts. Reactions from the scientific community. The buzz surrounding 3I/Atlas has sent waves through astrophysics circles. This object, an interstellar visitor with an unexpected trajectory and unique composition, challenges the very principles scientists have long relied upon. Many experts initially approached it with cautious skepticism, but as data streamed in, spectroscopic analyses revealing an unusual mineralogy, perhaps even signs of artificial processing, the tone in the community shifted dramatically. The initial shock was palpable. Astronomers drove themselves to the point of obsession, scrutinizing pixel by pixel, trying to decipher whether this was a natural anomaly or something extraordinary. Researchers are now openly speculating about the implications. The reactions range from awe to outright disbelief. Some scientists are whispering about the possibility that 3I/Atlas could be a probe or artifact, a product of a civilization far more advanced than ours. This idea sparks both excitement and deep unease, as it raises questions about the capacity of intelligent life elsewhere to craft interstellar objects capable of visiting our solar system. Others focus on its physical properties, the fast, hyperbolic orbit that defies conventional comet or asteroid models, the spectral signatures hinting at materials that are rare or unseen in our local universe. The discovery has ignited debates about the limitations of current observational techniques. Many researchers are pointing out that our understanding of interstellar objects might be fundamentally incomplete. Some are calling for a reevaluation of our models of cosmic matter transfer, suggesting that objects like 3I/Atlas could have been traveling through the galaxy for eons, potentially bearing knowledge or even technology that humanity has only begun to imagine. The sense of being on the brink of a paradigm shift is infectious, and community conferences are buzzing with theories, counter-theories, and heated discussions. Behind all of this, there's a wave of collective awe, an almost visceral recognition that humanity's view of the universe is changing radically before our eyes. The reactions range from scientists trembling at the possibility of encountering extraterrestrial intelligence to those quietly marveling at the universe's endless capacity to surprise us. Yet amid the wonder, there's an underpinning of cautious responsibility, knowing that every new piece of data potentially alters our understanding of cosmic history, and perhaps even our place within it. As more observations pour in, the scientific community remains poised, eager yet tentative, aware that what they are witnessing could revolutionize not only astrophysics but the very idea of humanity's cosmic companionship. Future investigations and speculations. The discovery of 3I/Atlas has thrust the scientific community into a state of heightened curiosity and urgency, prompting a cascade of future investigations driven by a combination of excitement and cautious skepticism. Researchers are now racing against the clock to understand its anomalous trajectory, which diverges sharply from known comet and asteroid behaviors. The way it shifts in brightness unpredictably suggests it might be shedding mass or perhaps even exhibiting some form of atypical activity that isn't entirely natural. Now, telescopes around the world are aligning their sights on 3I/Atlas, aiming to unravel its secrets through multi-wavelength studies, encompassing optical, infrared, and perhaps even radio observations. The desire to capture every fleeting detail about its composition, rotation, and velocity is almost palpable, as if everyone involved senses they are on the brink of a paradigm-shifting discovery. Speculation about what 3I/Atlas truly is has taken many forms, and the theories are as mesmerizing as they are unsettling. Some scientists ponder whether it could be a fragment of a larger, perhaps even artificial structure, an ancient relic or an interstellar probe that has somehow been broken apart. Others are exploring the notion that it might be a true interstellar visitor, bearing signatures of alien origins in its unusual composition or trajectory. If its makeup contains elements or isotopic ratios unfamiliar to us, it could redefine our understanding of cosmic chemistry and planetary formation. These possibilities fuel debates about advanced extraterrestrial technology, an idea that fires both hope and dread in equal measure. The more data that floods in, the more these theories seem to converge on the idea that we are observing something unprecedented, and the implications ripple beneath the surface of rational science. Looking ahead, the most pivotal investigations will likely involve deploying next-generation space telescopes and even possibly sending a dedicated probe to intercept or study 3I/Atlas directly. The prospect of capturing a close-up view, seeing its surface, measuring its outgassing patterns, or detecting any artificial signals, thrills the imagination. Yet, there's an undercurrent of unease. The unpredictability of its activity could pose unforeseen risks. Future research may also turn inward, focusing on modeling its orbit in even greater detail or testing hypotheses about its origin with enhanced computational simulations. Every simulation, every new piece of observational data feels like it could push us into an entirely new line of questioning. What if, after all, we're not just observing a curiosity, but encountering a visitor whose purpose we can barely begin to fathom? These prospects fill the air with a mixture of awe and fear, as the universe quietly whispers that it may be more mysterious than we ever imagined, just waiting for us to look closer. As the image fades and the cold silence of space takes over once more, you can almost feel the tremor of anticipation coursing through your veins. What 3I/Atlas is doing right now bends the line between understanding and the unknown, a cosmic dance that leaves even the sharpest minds breathless. You've seen the data, strange signals, unexpected trajectories, and felt the whisper of possibility that we're on the cusp of something extraordinary. It's as if the universe itself is holding its breath, inviting us to look closer, to question everything we thought was settled. This is more than just a scientific curiosity. It's a portal to understanding our place among the stars, a reminder that every discovery can challenge our deepest assumptions. And as we stay tuned, the potential for breakthroughs feels almost tangible, right on the edge of our collective reach. So, keep your eyes on the sky and your mind open. What's coming next might just change everything we know about the cosmos. Be sure to subscribe and follow us, because this journey is far from over. The universe is whispering, and together we're listening.